Welcome everybody that's joining us today. Really excited about today's webinar. The last 2 years, we've been collaborating with ITS America on this series around digital roadway infrastructure or digital infrastructure, depending on the audience you're talking to. This broad term addresses a wide range of system elements, a wide range of public and private partners that are within the ecosystem, delivering on the promise of digitizing our roadway infrastructure. We've talked about different use cases over the last couple of years. We've talked about freight, talked about emergency response, work zone safety, data exchange, transit signal priority, cybersecurity, just to name a few of the topics. We are closing out the series here in 2025 with a topic that's very near and dear to my heart. And I know I'm a real transportation geek when I say that that's near and dear to my heart. We're talking about connected vehicles. And I've assembled this panel today and really even sort of challenged the panel a little bit to have a different discussion than we have in a lot of these webinars. We're not just going to be geeking out about the technology. We're not going to be just talking about what may be, what's out there in the future. We're not going to be talking a whole lot about standards and those types of things. We're going to be talking about real world implementation and lessons learned. And what we want to get across today on those lessons learned is some of the pain points folks have had and how they've been addressed so that when you're implementing your connected vehicle solutions, hopefully you don't have to relive as much of the pain as they've gone through before. So that's really the objective, is to move from the theoretical discussions, the what maybes, into the what's going on and really try to help the industry move the ball forward in real world implementation. I'm going to be introducing each of my speakers individually and asking them to introduce themselves, their role within the company, and their role within this connected vehicle ecosystem. And in that first introduction, go ahead and spend a little bit of time talking about a couple key points that you really want to get across today in lessons learned side of things. They might be using some slides to help with that. They might not. It depends on what they need to really cue things up. We're going to then come back to, so I'll be introducing them one at a time, but with a couple minutes in between as they go through some of those key topics. Then we'll come back. I've got a couple questions that I've already got drawn up based on conversations with them before that I think will get things going. But want to encourage everybody to please use the Q&A function within Zoom to start sending us questions as early as you can. And to my panelists, when you're not speaking, help me monitor the Q&A list, and feel free to just dive right in with your thoughts on full or partial answers to the questions that are coming in. I'm hoping that we get a bunch today, so we want to get through as many of those as we can. And then when we get through our stuff, I'm hoping to reserve as much time as possible for any of the remaining questions. So with that, Shannon, why don't I start things off with you? If you'd like to kick us off today.
Yeah, sorry, Adrian. Gotta love technology. My computer shut down as this was starting, so I had to reboot. Thank you very much, ITS America and STV, for inviting us here today. I'm Shannon. Oh, let me share my screen. I should probably do that. Give me. And I apologize, it is not coming up right now.
Would you like us to go ahead and jump over to your colleague Thomas and have him go ahead and go, Shannon, let you deal with the technical things for a minute? It really won't take us out of it does say, okay. Yeah, no, looks like
okay. All
All
right,
right.
apologies. Got, tech girl can't figure out tech. It's a pleasure meeting everyone. Thank you again for having us here today. As Adrian stated, I'm Shannon Bailey. I'm the Senior Director of Sales for the Public Transit Division at Miovision Technologies. Just a little background on me. I've been with Opticom for 5.5 years with over 15 years of transit technology expertise in public transit. As an active public transit advocate, I'm on the board of the American Public Transit Association Business Members Board of Governors, vice chair of the APTA AI Subcommittee, vice chair of the APTA BRT Policy and Funding Subcommittee, co-chair of the BMBG Cybersecurity and New Technology Committee, and a board member for New York Public Transit. Really excited to be here today to represent Miovision. At Miovision, we're transforming how cities move with intelligent mobility solutions that address different traffic needs by enabling various applications in the Miovision One platform. This allows both private and public sector organizations to leverage more powerful and intuitive platform with an approach for a more holistic and innovative smart city by doing more with less. I'll be discussing cloud-based transit signal priority and emergency vehicle preemption infrastructure, use cases, and some lessons learned through these real-world deployments. And my colleague, Thomas Bauer, will dive deeper into real-world Miovision V2X deployments that go beyond EVP and TSP. So transit signal priority and emergency vehicle preemption has been implemented in North America for 60 years. Many folks will say it was one of the first connected vehicle technologies in the industry. What has changed from the original infrared technology line of sight advancements with radio and GPS in the early 2000s, and now cellular-based cloud applications, which are really shaping transition into full CV2X capabilities. By leveraging third-party hardware, integrated software applications, and leveraging additional CV2X standards, building out that digital infrastructure to make cities smarter and pushing to align with technology advancements is rapidly gaining momentum. The architecture shown here is highlighting real-world use cases where having flexibility in various architecture types is what's bringing these V2X deployments to life. By enabling digital priority control and preemption, agencies can move beyond traditional methods towards a fully connected ecosystem, one that dynamically adapts to on-road conditions, prioritizes critical vehicles, and then delivers measurable improvements in travel time reliability, which really drives data reporting and analytics in real time. This isn't just about giving the green light faster, it's about building smarter infrastructure that's safer and more responsive for cities that anticipate movement instead of reacting to it. By using available applications and existing infrastructures today, like for public safety, such as vehicle applications like Wayland, Samsara, HAAS. For public transit, you can use Swiftly, CADI VL API, GTFS real-time feeds, or even cellular modems for any of these vehicles makes it much easier to send that priority or preemption requested message to the connected intersection. So when looking at designing and then implementing a cloud-connected solution, I think the most critical piece is the connectivity. So putting in place technology that meets the requirements at an intersection is always vital, and that can be done through NTCIP 1211, 1202 standards, network communications through cellular or fiber, or directly through an ATMS, or in our case, the Miovision core device. So in many of these cases, cities and vehicle stakeholders can really leverage architecture that exists today to connect for the future and beyond. With the transition to more cloud-based deployments, there also comes a number of challenges that we've seen in the wild, as Adrian has alluded to. As transportation agencies transition towards cloud-based priority and preemption systems, the promise of real-time connected mobility also introduces a new set of operational and design challenges that must be addressed to achieve the reliability and the scalability. So while cloud connectivity offers unprecedented flexibility and data-driven optimization, several key factors continue to shape that path forward. And I'd like to say I put them into 5 themes. First, the consistency of standards across platforms and jurisdictions remains a fundamental challenge. With all the deployments we've done today in that V2X space for TSP and EVP, you still find very fragmented communication protocols and certification frameworks that can limit interoperability and deployment speed. For example, when looking at NTCIP 1211 as a standard, quite often we find it's not implemented the same way across a lot of the systems. Often a MIB version is required, which makes for additional customization. Second, network reliability is essential in ensuring mission-critical signal priority commands are delivered with minimal latency. Yet connectivity gaps and variable infrastructure maturity often creates performance risks. So in this instance, let's say a cellular network outage occurs. Certain environments can cause downtime, or cities' fiber gets cut, which I know a lot of cities are facing. When that happens, the network goes down. Third, there's a need for unified design policy. So as agencies move forward with architecture for cloud-based systems and connected vehicles, it's important to align with each of the stakeholder, the municipality or the jurisdiction. So again, having that policy across all entities for adopting timing plans, determining extension policies for green time, standardizing requirements for GTFS polling and latency are all items that fall into that critical bucket. So compounding these issues with many of the agencies do face a lack of capacity. So both in terms of network bandwidth and organizational expertise, sometimes limitations with resources and having physical people, coordination between responsible parties to fully manage and scale these solutions. I think quite often you see, even after deployment, conversations come up amongst the stakeholders of who's maintaining that solution for the long term. And then finally, mobility methodology, how cities define and measure movement, efficiency, and safety in a connected environment, but must keep pace with the technology to ensure equitable and effective outcomes. As we see mobility evolving in cities today, there are many challenges faced. It's critical to have these methodologies in place when selecting the technology architecture, the applications, and the solutions. Everyone's facing mobility challenges. So thinking more about the methodology and the alignment of the technology to transverse and evolve with the city as well as the stakeholders. So together with these challenges, defining the landscape for innovation and collaboration in cloud-based priority and preemption really requires coordinating leadership between the public agencies, the tech providers, policymakers to really build a resilient, future-ready transportation network. Thank you, Adrian. I'm going to hand it back to you.
Thanks, Shannon. And as you mentioned, transit signal priority and emergency preemption have been around for decades, and they really were one of the earliest connected vehicle applications in the sense of vehicles communicating with transportation infrastructure, but not really connected vehicle in the way that we're defining it these days with industry standards. I mentioned at the beginning we weren't going to be talking a whole lot about industry standards, but we will from a lessons learned standpoint, and you're bringing up some great examples there. But I do strongly encourage any clients that are out investing in infrastructure, putting them on your poles and putting them in your buses. Let's stop investing in infrastructure that can do one or two things only. And if you're putting out a bucket truck and you're putting a radio, don't allow it to only do TSP and EVP. If there's an opportunity to future-proof your signal for the connected vehicle of the future and using the standards that you talked about, 1211, 1202, working through the hurdles that come along with that, but future-proof it for a connected vehicle. So that's lesson learned number one. And thank you so much for that. Thomas, you ready to pick up there? And we're all going to need to pick up our pace a little bit to make sure that we got good Q&A time. So let's hit it.
Sounds good, Adrian. Yep. Let me see. Is it working?
Yeah, it looks good here.
See my screen? Perfect.
Yep.
Yes, good afternoon or good morning for those of you on the West Coast. Thomas Bauer, my name. I'm the VP for V2X sales at Miovision, so I don't have to talk much more about Miovision since Shannon just did that already as my colleague here earlier. I was prior to acquisition by Miovision from TTS, I was the founder and CEO of Traffic Technology Services. Some of you may know me through that. 35 years in the traffic industry, PE, PTOE, and last 12 years basically focused primarily on V2X and V2X applications. Hang on, too many screens here. With that, actually, let me start this video and let it run in the background, because obviously the first question would be, why am I even here? Why am I on this panel? What have we done to basically justify or talk about our experience in that field? Well, we power automotive consumer applications since 2016. We are in various different brands of the VW group, from Audi to Lamborghini, Bentley, Porsche, Mercedes North America, Ford China. So we have done quite a number of automotive OEM implementations of consumer applications of V2X use cases. We are currently at about 70,000 intersections in 7 countries in North America and in Europe. And over the years have basically delivered about 10 trillion SPAT messages to about 2 million vehicles. So that's sort of the experience we have to, as I said, why am I even here? Having said that, let me move to the next slide here. The first use case lesson learned, I would say, is the use case has to be very, very clear. If there is no use case, there is really no business case. And if there's no business case, there will be no commercial application or an adoption by anybody in the automotive industry. And therefore, you will just have another demo, another pilot that will last for a while and then will go away. So that clear definition of what are we trying to do and who is going to pay for it, which is the next question, is critically important. We have done a lot of research with different automotive manufacturers, and it's very clear. They're all almost aligned exactly what drivers will pay for, which is mainly convenience and their own safety. That means applications such as red light countdown, clearly a convenience factor, green light optimized speed advisor for efficiency gain, and red light assist. Those are the use cases, the primary use cases drivers will pay for. But what drivers will not pay for is the safety for somebody else. In other words, if you want to protect VRU, and that's actually the video I was going to run here in the background, you want to do that, you have to pay for it as an agent. Cyclist. The driver will not pay for somebody else's safety. And vice versa, from a government agency, that VRU, that general safety is very important. That makes sense. And a government agency will and should not necessarily pay for drivers' convenience. Having said that, so use case, business case, very, very important. The next one, I would say, standards from our experience are not the end of all, they are the beginning. You talk about standards, obviously, SAE J2735, MAP and SPAT are the key standards in our field of business. But from there on, there's a lot of different further definition that are just not in the standard alone. The standard, I always say, are defining where the bytes fit and what each byte should mean. But the content inside that standard is very, very important as well. And let me just give you 2 examples for that. On the map coding, yes, we all know how map coding is defined from the standard, but there's lots of different flavors, if you so will. One of them that comes up all the time is, for example, what do you do when you have an upstream railroad crossing in the approach to the signalized intersection? How do you code that in the map message? Do you code through it? Do you stop it? What do you do with that? That's just one of many, many, many examples where you really need to create what we have internally in the company, a coding standard that everybody follows when we have created by now 300,000 map messages. Each one of them is following a very clear coding guideline using the standard in the end. And on the SPAT side, it's the number one aspect is always prediction, right? The prediction horizon is critically important for all the automotive applications that follow it. What you see in the screenshot is an image in an Audi that tells the driver already, be prepared to stop. The signal in the distance is green, but the display in the driver tells him already, hey, this signal is about to turn red, to get into it's a red light assist, basically giving you enough advanced warning that by the time you get there, this signal is likely in a transition in a clearance or already in red. These type of predictions are very, very important for the use cases. And again, you have to follow your product, your SPAT message has to follow and be very consistent so that the user on the other end, the automotive, can build an application that works consistently through all their different areas where the vehicle is being sold. And last not least, I would say is very important that is often not understood, I would say, from the public sector as much, is the adoption hinges on coverage. Any product manager will always have to look at, and that is the same anywhere in any industry, what are the user benefits that people get from their product decisions. And for an automotive product manager who is responsible for a brand or maybe even just the model itself, a model line, that means, yes, the use case itself, the application, but secondly, how many locations is that use case, is that application being, can their customers experience it? The number that we've been given very clearly from every OEM out there is basically 25% of intersections coverage to get started and a midterm target of 50% coverage. What that means is if you're looking at, and Miovision actually has gone through and counted every intersection, signalized intersection in North America at 333,717 on that specific day, if you so will. That means if we have 25% coverage, we're looking at about 80,000 intersection coverage before it becomes attractive for an OEM customer. With that, back to you, Adrian.
Thanks, Thomas. A couple really killer key lessons learned there. The business case side of this is so critical. Like, we have this entire ecosystem of providers, whether with edge devices, with central data center or data exchange platforms, with distribution. And at the end of the day, everyone's saying, yes, but I have this available. I need somebody to pay for it. And then that last point about coverage, and coverage not meaning sort of cell coverage meaning what is the penetration rate of these applications on the driving infrastructure. And it's got to hit a tipping point before the OEMs are going to care. And that is so critical. We're never going to achieve the benefits of the digital roadway infrastructure and the connected vehicle promise if nobody is receiving it.
Yep.
Brock, I think this might be a topic you might want to pick up on a little bit too, as we hand over to you. Thanks, Thomas. We'll come back with some questions, and maybe, Thomas, we'll give you a breather here, and you can take a look at that Q&A. You might be able to help out with one of the first questions there. So, Brock, why don't you take it away for us here?
Excellent. Let me get us pulled up here. Okay, great. Can you guys see my screen, Adrian?
Yes, sir.
Excellent. All right. So we'll dive in here. I see a lot of familiar names and faces in our gallery of attendees here. But for those of you I haven't had the opportunity to meet yet, my name is Brock On. I'm the Vice President of Product here at HAAS Alert. Just by way of background here, I joined HAAS Alert nearly 7 years ago now, initially sort of in like the communications and marketing side, selling directly to public safety fleets, our digital alerting solution, which we'll get into in just a moment here. We sort of rapidly began expanding into other use cases and markets that needed digital alerting, markets like towing and roadside assistance and construction. And then in 2021, we began delivering digital alerts directly to automakers in production vehicles. Since that time, I've had the privilege of getting much more involved in policy work and the broader sort of V2X efforts at a national level, especially through ITS America. I became the co-chair of ITS America's Beyond 5.9 V2X committee in 2023. And in that committee, we are focused on rolling out clearer guidance and deployment objectives and case studies around V2X use cases that don't require direct 5.9C V2X. In our case, things like networked V2X. And then this year at HAAS Alert, I've had the privilege of moving out of the communications and marketing side and overseeing the launch of a dedicated product organization here. So I have the opportunity to work directly with our automaker partners, our fleets on the ground that are deploying and equipping digital alerting, and then also policymakers and stakeholders across the ecosystem who all play a role in getting this technology deployed at scale. For those that aren't familiar, this is what a digital alert is, and I'll just show you that experience in a drive demo here. So you'll see that this driver is getting a notification in their car that there's an emergency vehicle ahead. They're coming up a hill, they're coming around a corner. They don't see it, but they're coming right up on a stopped emergency vehicle at an incident. And so they receive this alert 20 seconds upstream before they actually reach that hazard. And that's really the core of what digital alerting is. That's the role that it plays. Today, HAAS Alert is delivering real-time alerts to nearly 3 million production vehicles nationwide. I mentioned here Chrysler, Jeep, Dodge, Ram vehicles. These are Stellantis vehicles 2018 and newer, as well as Volkswagen model 2024 and newer. You'll see here, we've also demonstrated with other automakers like Mercedes-Benz, the frontier of what these digital alerts might look like in the future. We are doing these alerts as well on Waze. We are one of the largest third-party data providers nationwide and globally to Waze, directly from all the fleets that are equipped on us. And we deliver those alerts as well in Apple Maps. Apple Maps is another navigation app, obviously comes standard on most Apple devices. And now our alerts are beginning to proliferate there as well. The purpose of digital alerting is really about safety. And we have data now that demonstrates very clearly with our automaker partners the benefit of digital alerting. We can demonstrate that if you measure the speed of a driver in the moments before and after a digital alert, on average, we see a 17% reduction in speed. So this is really proof positive of the sort of promise of V2X that is an industry we've been pursuing for years, right? Which is we know that this connectivity can be used to drive meaningful behavior change on the road, even before we get to automation. Just by getting information to drivers about hazards that they're coming up on, we can dramatically reduce the likelihood of that collision. What you're seeing here now is the expanded universe of things that Safety Cloud, which is our digital alerting platform here at HAAS Alert, is delivering alerts around today. It's not just emergency vehicles we found that have the need for this ability to communicate. As you all know, there's a broader array of stakeholders here, including towing and recovery fleets, roadwork, construction vehicles, utility and maintenance vehicles. There are needs for infrastructure to communicate directly with vehicles and drivers, as the Miovision team has eloquently demonstrated here. There's the need to get drivers information about things like severe weather. So all of these things are data sources that automakers have demonstrated a clear desire to get in. And the benefit of doing this over a platform like Safety Cloud is that we're doing this over cellular network connectivity. And so automakers are more easily able to deploy this at scale because they already have the infrastructure in place in these vehicles. It doesn't require adoption of a new technology. A partnership is a big part of this. I'm demonstrating here just a snapshot of the partners that we work with across the ecosystem to enable fleets to equip us and then to deliver these alerts downstream. As you can see here, there's emergency vehicle manufacturers. There are large dispatch organizations. There's emergency equipment manufacturers and telematics solutions. And all of these stakeholders play a role in ensuring that fleets have access to this connectivity so that they can actually get protected on the road. This is a quick snapshot of what this deployment looks like today. I wish I had a prettier map, but what you're looking at here are the headquarters of agencies in North America that have deployed Safety Cloud digital alerting. We have over 5,000 fleet deployments nationwide now, and that's public and private. So it is fire departments and police departments, it is tow truck companies and utility companies, it is construction vehicles and school buses. This is what that activity looks like at scale. In the course of a month here, you're seeing the coverage of digital alerting as it unfolds across the United States. And all of these points represent essentially someone in the road that needed protection. They're responders, they're road workers. When you get into a specific state and look at specific communities, you get a much more granular look at just how saturated this coverage is, both in terms of who can participate and also where they work. And then in a city like Detroit, you can see that there's not many roads that go untouched by these fleets. Oftentimes, this is obviously these types of hazards can appear anywhere on the roadway, and we see that every day here at HAAS Alert. And this right here is our vehicles that actually receive these directly in the dashboard of the vehicle. So the story here, really at a macro level, some of the lessons that we've learned at HAAS Alert. The first thing is, and a lot of this is actually going to rhyme with Miovision's presentation here so far, you really ought to prioritize immediate outcomes. You should be deploying for today, not for tomorrow, for the outcomes that you can achieve now. I think for a very long time in this industry, we've been building towards a future that was based on standards, that was based on a goal of national adoption around a top-down framework. But there's immediate things that you can achieve today with solutions that are deployed at scale that will get you day zero benefits and immediately drive transformation in your local community. In a world of limited resources, you should be optimizing for your time to value. You can reach many more drivers today out of the box than you could have 5 years ago or 10 years ago, and that provides a very viable path for deployment. Another thing that I want to say, and this might be a little controversial, but focusing on that connectivity, as Miovision said, just getting your community equipped is a key part of this. I also argue fleets over feeds. Feeds solve some problems, but we find that they actually create a lot of other problems. And for automaker partners in particular, there's a lot of danger and lack of trust in feeds as opposed to direct connectivity to things that are on the ground. If you're getting ground truth data in place, regardless of how you're deploying and equipping that, that's always going to unlock the most value and impact down the road for all the expanded applications that are going to rely on that. And the biggest part of this, the sort of overlap between these 2 points, is to really focus on your network. You know, the most sustainable networks are built on hyper local foundations. We have seen so much transformation at HAAS Alert just by getting 2 fire departments to get connected to Alert and then share their information with one another. Just that base level connectivity and shareability unlocks a remarkable array of transformations that drive real impact in people's lives. And that's the real thing we're all trying to do here, right? Is actually make the world better for people. And those basic investments are really something that I think a lot of people overlook in service sometimes of pursuing a great grander goal that requires a lot of action by a lot of other people that you don't control. So with that, Adrian, I'll hand it back to you.
All right, thanks a lot, Brock. Wonderful stuff there. Yeah, partnership is key, and that 17% reduction in speed, that's a great stat to show the impact of this. You talked mostly about I would say sort of vehicle to vehicle, and you guys have one of the I think arguably, if not the biggest base of examples of real world connected vehicle V2V connections over network that anybody's got out there. When we come back into the Q&A, be ready. I'm going to pitch you into a little bit more of the V2I side of things and construction work zones and especially from the perspective of the OEMs that you're working with. that are receiving that data and how they want to receive it and what's good enough and what isn't okay for them to be sharing that. I think that's a really, really critical lesson learned, because again, we can do all this great stuff on the providing. If there's nobody listening and nobody receiving it, we're not achieving the true benefits of connected vehicles. So I'll be queuing you up in a little bit. You got a bunch of questions in there, but I still want you to stay a little bit focused on what our next speaker is going to be talking about, because I'll get you guys kind of playing back and forth a little bit. Neal, if you can get queued up here. So Neal, I'm going to let him introduce himself, talk about the work he's doing at the university, some great research that they're leading with, but even beyond the great research, getting into practical applications and working together with state DOTs on deployment, and again, lessons learned on deployment. And one of the things that we don't talk nearly enough about in connected vehicle and in this whole space is the technology is one of the three legs of the stool. And without the people and the process implementing the technology and implementing the standards, again, we're not achieving the benefits of connected vehicles. So kind of tossing a little bit of a cue there to you, Neal. Please take it away and introduce yourself.
You bet. And can you see my screen?
Yeah, but you switched. You're not doing the PowerPoint presentation mode.
Okay. Let's see.
It's always the beauty of the multiple screens.
How's that?
We can see your slide and the next slide right now.
Okay, so well, let's see. Is that better?
We go. That looks right.
All right, thank you.
Thank
you. You bet. So it's a real privilege to be on this call with this panel today. Greetings, everybody. My name is Neal Hawkins. I'm with Iowa State University, and I'm a professional engineer here in Iowa. I serve as the Associate Director for the Institute for Transportation, which is part of Iowa State University. And I work with a really talented group of colleagues, and we focus a lot on operations. I serve also as the Iowa DOT's Traffic Operations Research Engineer. And so my comments are going to come to you probably more from an agency's perspective and experience and lessons learned, which I think will fit pretty well within what the previous speakers have talked about as well. So I'm just going to jump right in for time. I'm going to start with something back in 2020 with the SPAT Challenge, which was this amazing broad approach of getting agencies to put this technology in intersections. Iowa participated. We worked with 4 communities. We did all the configuration and installation and everything else. And, we found as researchers super interesting, really cool. We tried for a long time to get, notification of how many vehicles are receiving or transmitting. And at the end of the day, when the DOT had to make decisions about whether to keep going with this or do anything else, it wasn't a hard decision for them. They could not directly tie to what Adrian just said. Are there people using it right now? And so back in 2020, 2021, we couldn't say 89 vehicles out of 100 received a signal or transmitted at these intersections. The city, the agencies also didn't see that as well. And so one of the lessons learned there has already been mentioned, that deploying for today for outcomes you can achieve tomorrow. This probably wasn't our best step forward, and a lot of these agencies didn't. They felt overwhelmed with it, but they felt, where is the direct tie to the public that are on the road today? And they didn't see that. So that's one of the lessons learned, is tethering our technology rollouts to more immediate outcomes and visible outputs. The second thing is work zone and work zone data exchange. This is an area where you could look at most state DOTs 511 and find lots of examples, if there's cameras available, to where they say there's a lane closed and you look at the camera that's nearby and it isn't. We do a lot of giving up of our roads to contractors, which is unfortunate from the traffic control perspective. And many agencies aren't 100% sure of which lanes are closed at any one time. And so we found that there's a real lack of work zone lane closure information in the Iowa DOT's 511 system. And we wanted to start focusing on that. And this is about 5 or 6 years ago. And so one of the things we started doing is looking at other ways of getting the information reported. The inspectors are all super busy inspecting concrete and rebar and batch tickets. They didn't have time to do this. And so this protocol basically said, if you bring an aero board into our state and turn it on the back end through the manufacturer, we want to have a feed that says the aero board is here at this location, and this is the aero indication going on. And we were able to feed that directly into our OpenTMS, which is our ATMS system, and be able to see those as well and look for work zones that weren't compliant, as it was a requirement at that time on DOT roadways. So that was a great start. And then it was a great collaboration with these manufacturers. Everything was going well, and we were basically doing some certification here to make sure if you new contractor or a new vendor brought an aero board in, it would be compliant. Luckily, that became more of a national standard and incorporating into WZDX. And so now at this point, we're able to take those feeds. We know what's scheduled for lane closures. And because of the feeds we're getting from aero boards, these device feeds, we're able to say, hey, this is verified. And so we can verify that the construction is underway, or that the lanes are closed. And that's been a really nice way to assure some quality control versus just saying, well, the contractors just need to do better. We're also really excited about smart devices, other things like temporary traffic signals and others. We use a lot of connected vehicle data for work zone applications, from queuing to speed management to generating and displaying slow and stop traffic ahead types of messages. So we're finding just unlimited opportunities to use data to generate messages that are used daily in the work zones, in addition to working with our Iowa State Patrol on other kinds of things. So this is an evolution. It really is. As we continue to try and improve data in the area of work zone, and companies like HAAS Alert and others are able to share that information, it's just amazing opportunities to get messages out. The last thing I want to talk about is just a use case that's very basic. You heard Miovision, both Shannon and Thomas talking about preemption. But this is back to the agency level. And there was a supervisor out of the district to the left of this map, which is Adele, works for the Iowa DOT. We have this Highway 6 corridor. It's about 12.5 miles. It's got about 20 traffic signals, goes through 4 cities. And one of those cities has the highest growth rate of any city in Iowa. There's a couple of hospitals nearby, lots of sports and entertainment, and daily congestion. This picture, you can see, you get a lot of snow here in Iowa. And of course, it's an issue for snowplow progress. The corridor runs between I-80 here on the bottom and I-35 on the right. And so the crew, the supervisor was following one of his crews through Waukee, which is one of the communities. And of course, they're stopping it, unfortunately, at almost every red light. It's during the 4 to 6 p.m. time frame, and it's snowing really heavy. So it's taken them roughly about 80 minutes to get a round trip on this corridor. He sees a city vehicle from the city of Waukee go and get preempted going on the cross direction. So they start talking to him and asking, can we get one of those? And they go through a process, get some letter authorizing it, as well as some rules of the road. And we're able to make it happen in addition to the other 3 communities. And so this is a crew and a supervisor that they only got 2 of these in the trucks. They were so excited because they went from a before of 80-minute round trip down to 45-minute round trip during congested times to be able to make this run. So they reduced it by roughly half. And this is very old, 30-plus-year-old type of technology, and we're fortunate that the cities all had the same style of equipment. So a couple of lessons learned. One, if you get technology that works and eases the burden and pain and helps crews be more efficient, they will be self-promoters of it as much as we are. But the technology that you can't have roadblocks of, well, this is on inconsistent standards, as Shannon mentioned, across platforms. And it just needs to work. And so it's got immediate benefits. They're excited about it and they use it. So that's kind of an example there of using a very old technology. And so that's really it. I'll pause there and we can answer more in the Q&A.
Thanks so much, Neal, and thank you to all my panelists here that are helping stay on top of all these questions, because we have so much to get through. And when I saw them starting to pile up, I was getting a little worried. But I appreciate you guys work beavering away in the background there. And Neal, be ready, because that second part that you're bringing up there on work zone data exchange is one that I'm going to want to dig into a little bit deeper with you and Brock. Here's a space that as an industry, we have spent a lot of time. We were able to get the OEMs to get most stakeholders to buy in on safety. We get the DOTs. Everybody wants to keep our construction workers that are in harm's way safe. It's a space that we've spent a lot of time on standards definition. But as I'm going to get Brock to talk about in just a couple minutes, the information's only as good as the way that it gets implemented. And so I'm going to dig in deeper. Our last speaker here, Carole, I don't normally do this. In fact, I never do this, but I'm going to do a little shameless plug. I'm not sure if it's shameless if I'm doing it for someone else, but Carole, after a long career in DOT that she'll be talking about there, started her own firm and will be a extremely valuable member of your team in helping deploy connected vehicle technology. You'll get a glimpse of that today. I wish I could give her a lot more time than we're going to allow, but as long as I don't already have her on my team for a project, I encourage anybody to grab her, put her on your team, and you'll see why. So Carole, please introduce yourself. Tell us where you come from, what you're doing now. And as you talk through lessons learned, whatever caveats you need to put in, I understand. So take it away.
Wow, Adrian, thank you for the plug. I was going to explain why I'm here, but I think Adrian just did it. So folks, hi, my name is Carole Delion, and some of you may know me from when I was at the Maryland State Highway Administration. I have since left. I hear folks still ask for me, so I'm just clarifying. I have left the state DOT, but I am currently founder and CEO of my own company. And part of the reason Adrian just said what he said, I help translate some of what the industry comes up with to implement within the state DOT. And so I act a little bit as a translator between what really wants to happen and what can happen from the state DOT or any agency who's trying to implement connectivity. And one of the things I want to highlight right now for you is that if you haven't already picked up on this, we are no longer talking just about an RSU on the side of the road and an OBU within the vehicle. That is still part of the conversation, but the connected vehicle narrative has expanded significantly within the past, I'm going to say 2 to 3 years. If you are not on that bandwagon now, you should be after this webinar. We have seen across several agencies, across several committees, across all of these conversations, the narrative change from we have more than just radio, so we have other capabilities that will benefit the public. Now, I love what Thomas said about someone being in their own vehicle, not really caring what happens to somebody else outside of their vehicle. That is absolutely true. And from a state DOT perspective or an agency perspective, you are in fact on the flip side. You are trying to help everybody, but not everybody cares about everybody else. So how do you make that work? How do you translate what can happen with what you want to happen? A really big part of how we are succeeding in the implementation of connected vehicles is whether you are in the room, state DOT, agency, whoever you are, with the industry. You saw just now, you just got data hosed with a lot of information. They are moving forward. They have standards that they use within their own companies. When they see a WCDX feed, they ingest it, they process it a certain way, and then they push it back out to the public. Are you talking to them about how your WCDX feed works? If not, you need to be in the room with them. You need to be in the SAE rooms. You need to be in the TRB rooms. You need to talk to them one-on-one and understand what they're capable of, and they need to understand what you're capable of. This is why I actually really appreciate ITS America, a little plug there, because they bring everybody in the room and they sort of force you to talk to each other and understand that a business has to have a bottom line. They have to make money. Sorry, it's the truth. But the public needs to be safer, have better resiliency, have mobility, we have needs as a whole. So how do we bridge the two together is really important. If you are not currently capable of putting out a project, I assure you that your state has money, but the success of how that money comes in depends on how well you can translate or talk to your partners within your own agency. The successful agencies that I have seen out there, and I'm going to put a plug out there, I'm seeing him on the call, Darren Anderson in Texas, Blaine in Utah, and there are others, many others. They learned how to talk to those who have the money and then bring that money down to their projects. They understand that the National Highway Performance Program, the Highway Safety Improvement Program, they all have needs, but you can talk to them the way that you need to implement an industry level turnkey solution that will help the public as a whole. You also have changes in how the industry reports their data. For example, Brock, I'm going to point him out. The behavioral response to the technology is really important. So this is a translator part that I'm going to, pitch for you guys. When the public sector is able to demonstrate that there is a change in behavior, that is huge. I remember when we tried to implement HAAS and we were like, how do we justify this? Well, if you're able to say, I am actually helping people slow down at a scene, incident scene, a work zone scene, whatever scene, you are able to justify more funding for longer term. And that is of huge benefit to the public. So see how you can tell companies like HAAS and others how they can change the way they do business to help you make the business case for the deployment of that technology. And so I'll wrap up really quickly by saying whoever comes out, this is a business pitch, give my name at the end, right? Credit. Whoever comes up with a translator tool that can take all of this data feed and say, yep, just give me your WCDX in whatever format you have it, and I will translate it for somebody else to pick it up. If you can do that with all of the feeds out there as a business, you will make a lot of money. So I'll write back to you, Adrian.
Well, you helped me a little bit on the time side of things, so I don't have to do my first part of this, which is, for years, I used to have a slide years ago, and this will date it, that said DSRC does not equal CV. Where there was that mindset for a very long time. This is an and situation between edge radios and over the network. There's applications that are necessary for ultra low latency. When you're a car that's about to turn right into an intersection and your LiDAR system says there's pedestrians here, you need ultra low latency and you need to be able to communicate directly to that car immediately. But if you're telling a car that there's an icy patch up ahead or a construction work zone in a mile, I don't know that you need that ultra latency. And then I've got other clients who, like, I cannot pay for a roadside radio on all my freeway system. I can't even pay right now to maintain CCTV cameras that I put out a few years ago. So it has to be a scalable solution, and it has to be that and. So thank you for queuing that up a little bit. And boy, we are going to run out of time here, just like I was afraid. One quick thing I want to dig into, and unfortunately, Shannon, we might run out of time and not get to come back to the TSP, which is one of my other passion areas. But Brock, this issue of work zone safety, everyone can turn their cameras back on because we're going into full Q&A now. work zone safety, when you started working with some of the OEMs, and Stellantis was your first partner, and we're so excited working with your state DOT and having work zone safety information. Tell me what happened. What was the data looking like, and how did your OEM partner respond?
Sure. Well, as soon as we began ingesting WZDX feeds and began alerting to them, we got immediate feedback just based on the way that we work with our OEMs. And we very quickly got a wave of feedback. The drivers were getting alerted to work zones that weren't actually there, that they never encountered. And we later learned that it's just because the method of maintaining those feeds was still a manual human process, right? So the difference of uploading a work zone a few days before it goes live or leaving it up on the feed, even though it finished up a few days ago, has a massive impact on whether or not an OEM can trust a single data source, let alone an entire standard around it. And this is why I just raised this point that like feeds are typically a step in the direction to solve one set of problems. But if your goal is communicating to automakers, there's other and better ways, unfortunately, today that you've got to sort of get that message in that go beyond just sort of a standardized feed.
And so, Neal, working with your state DOT, I mean, I understand that they recognize this, and you've been working with them on the people and process side to try to help deal with that part of this. Can you tell us just a little bit about that, and then maybe Carole, I'm going to come back to you again on the lessons learned on the deployment side of things. What can we share with our remaining audience here so that they don't have to experience as much pain?
You bet. And so Brock characterized the data problem pretty well. We also, related to that, are tired of our own crews getting hit by vehicles or being surprised. And there's times they're out there pulling up, doing something, and then moving on and stopping and removing something else or whatever they're doing. So these are temporary maintenance actions. But all the trucks, 900 plus trucks, have AVL and a forward-facing camera and a feed, and so we're really trying to work with folks like Brock, like we can provide. We're working hard on the data quality, not just for permanent work zone, but for this temporary stuff that seems to really surprise a lot of people, and improve the quality of those. Started a lane closure system, other things that provide more assurance of the live, closed, or open status of lanes across our state.
Carole, do you have anything that you can add with just a quick blurb, or is that?
Yeah, I mean, it's hard to give a specific, but if you have to commit to whatever you're going to move forward with. If your standards are whatever it's going to move forward, then stick to it, because if the more you change, the more confusion you're going to give whoever you're pushing this out to. So if you have one lesson learned, like stick to what you're doing and don't change it so much. Obviously, lesson learned from DSRC was that we kept changing things and it didn't work out. So
one last, and unfortunately, I'm not really going to even phrase this as a question for you guys, because I think Victoria probably needs the last minute of this as a cleanup minute. But Shannon and Thomas, one of the things that I appreciate with Miovision having Thomas's world and Shannon's world under the same roof is you have that inherent clear understanding that a solution at an intersection that just does TSP or just does EVP doesn't ready that intersection for the work that Thomas's group needs to be able to do at that intersection. And if we can be communicating with that controller with industry standards in all of those applications, we're truly readying that investment for the connected vehicle future. So I think I've got to give it back to Victoria to wrap us up. Guys, great job today. Thank you to my panel, and thank you to everybody that stuck around here for a full hour. Don't know how many questions we still had remaining. Looked like we got through a whole bunch of them. Victoria, do you want to wrap us up?
Absolutely. Thank you everyone for attending. We will have a recording of the webinar posted on the ITS America website shortly. And if you have any questions or would like to follow up with additional questions, you can email membership@itsa.org. Thank you, everyone.
Thank you.
Thank you.
Thank you.